I am Ramasubbareddy. I am your physics faculty. Today we are going to discuss about atoms, module 2. In module 1, we discuss the concepts. What is J.J. Thomson model? What is the experimental setup to find specific charge of an electron? And then what is Millikan oil drop experiment? Okay, what is the charge of electron? What is Bohr's model? What is hydrogen spectra? What is radius, velocity, time period? Okay, these are all concepts we discussed in module 1. Now we are going to discuss the problems related to module 1 and quick recap on the synopsis. We'll discuss the concepts in detail. I will share that. We'll discuss the concepts in detail. We'll see the quick recap on the all formulas so that it will be easy to do the problems. So what is the de Broglie hypothesis? Okay, that also we'll discuss. And Millikan oil drop experiment. In that Millikan oil drop experiment, what we found, Millikan oil drop experiment, the charge of electron, that also we discussed. Millikan oil drop experiment, then J.J. Thomson model, when it is moving through electric and magnetic field, what is the velocity? Okay, that all concepts we'll discuss now. Wait a minute, I will share that so that we can discuss the all concepts. Okay, so first we'll see the quick recap of the concepts whatever we discuss in module 1. First one, when an electron passes undeflected through electric and magnetic field in perpendicular direction, what is the velocity? Velocity V is equal to E by V. Velocity V is equal to E by V. Then second one, that electron moves with some acceleration A in electric field. Then, so if electron moves with some acceleration A in electric field, from Newton's second law, we have F is equal to ma, and force due to the electric field, that is F is equal to QE. Then we can equate ma is equal to QE, then we'll get the acceleration. A is equal to QE by m, where Q is the charge of electron and E is the electric field and m is the mass of electron. Then we have the relation between electric field, potential and distance. E is equal to V by D, where D is the distance between two plates. D is the distance between two plates. Then next, specific charge. We find the Millikan oil drop experiment. From that we will get the charge of electron, that is E is equal to 1.6 into 10 to the power of minus 19 Coulomb. But before, J.J. Thomson found specific charge of electron. He done an experimental setup and he found 1.75 into 10 to the power of 11 Coulomb per case. Then sometimes they may ask in problems to find what is the specific charge of hydrogen or proton. At the time, that is E by m. So the charge of proton is same as the charge of electron, and this mass of proton, which is equal to mass of hydrogen, which is 1836 times of mass of electron. That we have to remember when you solve the numericals. Then in silicon oil drop experiment, this we found. I explained the experimental setup and in detail we discussed. This is our oil drop, Epigean oil or clog oil we took. That oil drop, if it is a stationary, if oil drop is stationary, that condition actually we call magic condition. So if it is stationary, gravitational force is equal to electric force, then the gravitational force mg and electric force q into E, then the electric field E is equal to mg by q. Okay, next, distance of closest approach. We discussed the concepts and distance of closest approach when alpha particles, a beam of alpha particles passed through the nucleus. Before coming to rest, there will be some distance. That distance we call distance of closest approach. Distance of closest approach R naught is equal to 2k. K is 1 by 4 pi epsilon naught. And the kinetic energy, then our distance of closest approach depends on Z if kinetic energy is same. And another formula we have, number of particles scattered at angle theta, then n directly proportional to 1 by sine to the power of 4 theta by 2. Okay, theta is the scattering angle. Then from Bohr concept, if electron is revolving, this electron is revolving in a circular orbit, then the time period t is equal to 2 pi r, that is the circumference of this circle, by v, velocity. This frequency we can written as reciprocal of time, v by 2 pi r. Then we know the velocity is c by 137. Then when it is revolving in a circular motion, the centripetal force is balanced by the Coulomb's inverse square law. We know the centripetal force mv square by r, and Coulomb's inverse square law is k, nothing but 1 by 4 pi epsilon naught q1 q2 by r square. If you equate that, we'll get velocity v is equal to under root of k q1 q2 by m into r. Numericals will use these relations. Okay, next, how to find the energy in hydrogen. We know when the electron exciting from one state to another state, it emits some energy, that is h nu, or also called photon energy. Then energy is equal to 13.6 z square by n square. This is our formula. Then the change in energy delta E is equal to 13.6 z square 1 by ni square, that is initial, minus 1 by nf square, that is final. Based on this formula, we'll find the energy, change in energy, or how much energy is required in order to move the electron from initial to final position. From Bohr postulate, if you take the angular momentum condition, quantization of angular momentum, mvr is equal to nh by 2 pi. And de Broglie hypothesis. This is the de Broglie hypothesis, lambda is equal to h by p, that is h by mv. What is de Broglie hypothesis? Every matter wave or every particle is associated with the wave. Every particle is associated with in the form of wave. That is the de Broglie hypothesis. Okay. Hydrogen spectra. We know this relation found in hydrogen spectra. 1 by lambda is equal to r z square 1 by na square minus 1 by nf square. In this hydrogen spectra, we have Lyman, Balmer, Paschen, Brackett, and Fund series. Their initial values and final values. Initial values and final values. Okay. Then for hydrogen, Z is equal to 1, and R, the Ribert constant is 1.097 into 10 to the power of 7. Okay, so this is all quick recap of our concepts, whatever we discussed in module 1. Now we'll see the problems. Problems first, J.J. Thomson concept. J.J. Thomson. First problem. We'll see an electron passes undeflected through perpendicular electric magnetic fields intensities respectively, then what is the velocity? Means we discussed in the J.J. Thomson model. This is the cathode. If this electron beam is passing, like experimental setup, roughly I draw here. Experimental setup we draw. We discussed this is electric field and this is magnetic field. If it is undeflected, means it is moving straight. If it deflected, S1 and S2. This is in the electric field. This is in magnetic field. We discussed in concepts. Okay. Now the electron is moving through perpendicular electric and magnetic fields of intensity. They gave electric field is 3.4 into 10 to the power of 3 Joule per meter, and magnetic field is 2 into 10 to the power of minus 3 Weber per meter square. Now this electron is moving in electric and magnetic field with perpendicular direction. Then what is velocity? We discussed in first synopsis the velocity v is equal to E by B. Then E is 3.4 into 10 to the power of 3 and B is 2 into 10 to the power of minus 3. So this will go upside 10 to the power of 6 and 2 into 3.4, that is nothing but 1.7. 1.7 into 10 to the power of 6. So our option 1 is our correct answer. Okay, next, second question. The ratio of specific charges of electron to that of hydrogen ion. We know specific charge is E by M. Okay, here they ask you to find what is the specific charge of electron and the ratio of specific charge of hydrogen. Okay, this also we discussed in concepts. Specific charge of electron is what? E, the charge of electron, M, the mass of electron, by E, the charge of proton, or charge of electron, or charge of hydrogen, all are same only, E. And here mass of hydrogen. So mass of hydrogen is equal to mass of proton is equal to 1836 times of mass of electron. Then which is equal to E by ME into MH by E. E get cancelled. MH is equal to 1836 times of mass of electron by mass of electron. Mass of electron cancel 1836 times by 1, which is nothing but what? Specific charge of electron by specific charge of hydrogen. So 1836 by 1, which is nearly equal to, if we check our options, 1840 by 1. Hence our option, which option is correct? Option 4 is correct. Okay, clear? So if you understand the concepts, it will be easy. Next, third question. An electron is accelerated in electric field. If you take this is our electron, this electron is accelerated in an electric field. This is our electric field. An electron is accelerated in electric field. How much is the electric field? 40 volt per centimeter. If E by M, here they gave the specific charge of an electron is E by M is 1.76 into 10 to the power of 11 Coulomb per kg. Here they ask it to find what is acceleration. We discussed in the first quick recap of the concepts. If the charge particle or electron is moving in electric field, it have the two forces from Newton's second law, that is ma, which is equal to q into E. Then electric field E is equal to E q m a. What we have to find? Acceleration. then acceleration A is equal to QE by M. If acceleration A is equal to Q by M, what is charge of electron and mass of electron? We know this value, that is 1.76 into 10 to the power of 11, and electric field we know how much, 40. So this value will get 7.04 into 10 to the power of 12. Actually here in centimeter, here is meter. If you want to convert this one, 7.04 into 10 to the power of 12 into 10 to square, then 7.04 into 10 to the power of 14. Hence our option 4 is correct one. Clear? Next, fourth one. Fourth one, if a water drop of mass, let us consider this is our water drop of mass given 3.2 into 10 to the power of minus 18 kg and carrying a charge 1.6 into 10 to the power of minus 19 coulomb is suspended. Now this is suspended in between the two plates of electric field. Let us assume this is one plate and this is another plate, two plates of electric field given G 10 meter per second square. Then the intensity of electric field. What is the electric field? We know when it is suspended, the gravitational force is balanced by the electric force, that is mg is equal to electric force Q into E. We need to find electric field E, that is mg by Q. Then m is 3.2 into 10 to the power of minus 18 and G is 10 and Q is 1.6 into 10 to the power of minus 19. Okay, then this power will go up, it will become 100 and 1.6 times of 2. So 2 into 10 square. Then our electric field E is equal to 200 volt per meter. Hence our option 2 is correct one. Next, we'll see fifth question, Millikan oil drop experiment model. In Millikan oil drop experiment, an oil drop of mass, what are the given mass? They given carrying a charge they given it. Here also it is stationary between the plates separated by a distance 5 mm. Then what is the voltage must be applied between the plates? Here we need to find V. Okay, what is our scenario? In a Millikan oil drop experiment, if we take this is the two plates, plate A and plate B, the electric field, let us assume the electric field in this direction, and this separated by some distance D, that D value how much they gave, 5 mm. So convert 5 into 10 to the power of minus 3 meter, and given mass is 0.64 into 10 to the power of minus 14 kg and the charge is 1.6 into 10 to the power of minus 19 coulomb. So here it will be the stationary. When it is stationary, gravitational force is balanced by the electric force. That formula we know. And another formula, what is another formula? If electric field, potential and distance, we have the relation E is equal to V by D. Now here it is mg is equal to Q is, now we'll substitute this one because we need to find our potential V. Then potential V is equal to mg D by Q. Okay. Then substitute all values. M is 0.64 into 10 to the power of minus 14 and G 9.8 and D 5 into 10 to the power of minus 3, and charge 1.6 into 10 to the power of minus 90. Okay, this power, this will go upside, it will become 10 to the power of 5, and here minus 3. Okay, that will cancel. After cancellation these values, we'll get nearly 1960 volt per meter. That is our final answer. So which option will get? Option 2. Okay. Hulfar scattering. On Hulfar scattering, we'll see the problems. So Hulfar scattering is an alpha particle are projected towards the nuclei of different metals. Alpha particle is projected towards the nucleus, that is nucleus of different metal with same kinetic energy. Okay, here it will be the same kinetic energy. Then distance of closest approach is minimum. So when distance of closest approach is minimum, if you consider this all elements, so distance of closest approach is what? From here to here only, now that is r0. Then what is the formula for distance of closest approach? That r0 is equal to 2k Ze square by kinetic energy. So kinetic energy is same. So this is constant, this also constant, this also constant, E, this also constant. Then it depends on distance of closest approach depends on Z, atomic number. If you observe, if distance of closest approach is more, our Z also more. But here the distance of closest approach is lesser. For which element? Z is lesser. So Cu, our Z is equal to 29. This is the less among the all elements. Then this is our correct answer. Okay, next. In Rutherford experiments on Hulfar scattering, the number of particles scattered at 90 degree be 28 minutes. Then the number of particles scattered per minute by the same file but 60 degree. They asked to find the how many minutes. Now if you see, we have the relation n is inversely proportional to 1 by sine to the power of 4 theta by 2. Theta is the scattering angle. Now can you write this as n1 by n2 is equal to sine to the power of 4 theta 2 by 2 by sine to the power of 4 theta 1 by 2. Here n1 is how much? N1 is 28 per minute and theta 1 is 90 and n2 is we need to find, and theta 2 is 60 degree. Then 28 by n2 is equal to sine to the power of 4 theta 2 how much? 60 by 2. Then sine to the power of 4 theta 1 is how much? 90 by 2. Then 28 by n2 is equal to sine to the power of 4 60 by 2 30. Here sine to the power of 4 45. Then 28 by n2 is equal to, this one is sine 30 1 by 2, 1 by 2 whole to the power of 4. Then sine to the power of 4 45, 45 we know 1 by root 2 whole to the power of 4. Then what will get here? 28 by n2 is equal to, this we will get 1 by 16 into 4. 4 1 ja 4 4 ja. Our n2 is equal to 28 into 4, that is 112. That is our answer. Which option? Option 2 is correct one. Clear? Next, Bohr's model of atom. Bohr's model of atom. First one, find the frequency of revolution of an electron in the first stationary orbit. What we have to find? Frequency. We need to find revolution of the electron. Okay, find the frequency of revolution of the electron in the first stationary orbit of hydrogen. So we know if electron revolving in a circular, time period t is equal to 2 pi r by v. We need to find frequency. Then frequency is reciprocal. Okay, v by 2 pi r. And what is velocity for hydrogen? That is c by 137. Then velocity v is equal to c is 3 into 10 to the power of 8 by 137. That is our velocity. We'll substitute here. Velocity we know. And radius for first stationary orbit is 0.53 angstroms, that is in 10 to the power of minus 10 meter. Okay, r naught also we know, it is nothing but this is r naught. Then our frequency f is equal to v, that is 3 into 10 to the power of 8 by 137 into 2 into pi is 22 by 7, and this is 0.53 into 10 to the power of minus 10. Then frequency f is equal to frequency f is equal to 6.6 into 10 to the power of 15 H. So this is our frequency. Hence our option 4 is correct one. Clear? Next. 9. In the Bohr model of hydrogen atom, the centripetal force is furnished by the Coulomb attraction between the proton and electron. If A0 is the radius of the ground state orbit, m is the mass and E is the charge of an electron, and epsilon naught is the vacuum permittivity, the speed of the electron. Okay, so the centripetal force, two forces, gravitational force. Centripetal force is balanced by here Coulomb interaction force, that is Coulomb's inverse square law. Okay, gravitational force is mv square by r. Generally, Coulomb's inverse square law is 1 by 4 pi epsilon naught q1 q2 by r square. But here our r is a naught and our q1 is e and our q2 is e. That is charge of proton and electron, both are same, that's why we are taking E and E. Then this equation is changed to mv square by r is a naught 1 by 4 pi epsilon naught E into E by a naught square. Then 1 a naught get cancelled. Then mv square is equal to 1 by 4 pi epsilon naught E square by a naught. Okay, then we need to find velocity. V square is equal to 1 by 4 pi epsilon naught a naught into m, numerator E square. Then velocity V is equal to under root of E square is E. Under root of E square is E. E by under root of 4 pi epsilon naught a naught m. This is our answer. Hence our option 3 is correct one. Okay. Next. Energy required to excite an electron, n is equal to 2 to n is equal to 3. Energy state is 47.2 electron volts. Then the charge number of nucleus. What is the charge number of nucleus around which electron is revolving will be? Now if we take, this is n is equal to 1, n is equal to 2, n is equal to 3. From n is equal to 2 to 3 it is changed. That is delta E is they gave 47.2 electron volts. Then they ask you to find what is Z. And we know the relation for delta E is equal to, we discussed first 13.6 Z square by n square, but here it is ni square minus 13.6 Z square by nf square. Then delta E is equal to 13.6 Z square for hydrogen is 1, but here we need to find Z value only, don't substitute. Okay, keep it remember. Z square 1 by ni square. Ni square is here 2 square minus nf square is 3 square. Then delta is, we know, 47.2 13.6 Z square 1 by 4 minus 1 by 9. Now if you take the LCM, 47.2 divided by 13.6 is equal to Z square. How much will get this one? 9 minus 4, 5, 5 by 36. We need to find Z. Z square is equal to 36 into 47.2 by 13.6 into 5. This will comes nearly 25. Then our Z is equal to 5. Okay, hence our option 1 is correct. This model is important. Keep in remember. 11th one. De Broglie wavelength of electron in the first Bohr orbit is. Okay, what is the de Broglie wavelength of electron in first Bohr orbit? In first Bohr orbit, that they ask us to find. Now we know from quantization of angular momentum, from quantization of angular momentum, that is L is equal to mvr is equal to nh by 2 pi, but here they ask for first orbit, then our n is equal to 1, then mvr is equal to h by 2 pi, then if you take this is 2 pi r is equal to h by mv. Okay, then here what is de Broglie's wavelength? Lambda is equal to h by p, then lambda is equal to h, p is the momentum, m into v. Now if we substitute, 2 pi r is equal to lambda. If this is 2 pi r is equal to lambda, what does it mean? Which is equal to circumference of the first orbit. 2 pi r is the circumference only now, circumference of first orbit. So hence our option 1 is correct one, equal to the circumference of the first orbit. Clear? Next we will discuss 12th question. Angular momentum of the electron in a third orbit of hydrogen atom. If the angular momentum of in the second orbit of hydrogen atom is L. Okay, so here we know same from quantization of angular momentum mvr is equal to nh by 2 pi. Okay, then here for third L3 angular momentum for third orbit of hydrogen atom and the second orbit of hydrogen atom, they asked to find the relation. For third orbit, that is nothing but n is equal to 3. So mvr is equal to 3h by 2 pi. Now for second, means our n is equal to 2, which is equal to mvr is equal to 2h by 2 pi. But here that L2 is nothing but L according to the question. 2 get cancelled, then our L2 which is equal to L which is equal to h by pi. Now if you see for L3 nothing but equation 1, from equation 1 for L3 is what? 3 by 2 h by pi. This h by pi is what? If you take this is equation 2. From equation 2, that is L, then L3 is equal to 3 by 2 L. Hence our option third is correct one. Okay. Then 13th one, they ask you to find here the de Broglie wavelength of electron in the second Bohr orbit. What is the de Broglie wavelength of electron in the second Bohr orbit? We know the relation of de Broglie and Bohr. What is the relation? Angular momentum condition, if you take mvr is equal to nh by 2 pi, from that we'll get 2 pi r is equal to h by mv, that circumference which is equal to lambda, that is 2 pi r, lambda is equal to 2 pi r. If it is a nth orbit Rn, then we have the relation for Rn is R0, Rn is R0 n square by z. We have this relation. Then lambda is equal to 2 pi Rn for nth orbit. Lambda is equal to 2 pi r h by mv, that is lambda is equal to 2 pi r. But here n, if it is a nth now, so here also we'll get n lambda. Okay, here we are taking Rn, that's why here also we are taking n for nth one. So n lambda is equal to 2 pi Rn. Rn is equal to R0 n square by z. So 1n get cancelled. Lambda is equal to 2 pi R0 n by z. So for hydrogen, z is equal to 1 and R0 value is 0.53 angstroms. Substitute here, lambda is equal to 2 pi, but here our n is equal to what? Equal to for second. So our n is equal to 2. If we substitute here and z is equal to 1, this is 2 pi R0, if we take as it is, n is equal to 2, z is equal to 1. So lambda is becomes, here I will write, our lambda is equal to 4 pi R0. Then 4 pi is 3.14 and R0 is 0.53. Then we'll get our wavelength is 6.66 angstroms. Hence our option 2 is correct one. Clear? Next, 14. Maximum wavelength for bracket series of hydrogen atom. Okay, well, we discussed Lyman, Balmer, Passion, bracket and fund, and initial values and final values also I discussed, Ni and Nf. Okay, here it is 1, 2 and so on, 2, 3 and so on, 3, here 4 and so on, 4, here 5 and so on. here 5, here 6 and so on. If you take bracket 4 and 5. Now what is our equation? 1 by lambda is equal to rz square 1 by ni square minus 1 by nf square. So 1 by lambda, that is for maximum, is equal to r z is 1 by n, here it is 4 square minus 1 by nf 5 square. So 1 by lambda max is equal to r 1 by 16 minus 1 by 25. Then 1 by lambda max is equal to r, this LCM 25 minus 16, 9, 16 into 25, 400. Now we need to find lambda max actually. That lambda max is equal to 400 divided by r into 9. We know r value 1.09 into 10 to the power of 7 meter inverse. We substitute lambda max is equal to 400 by 1.09 into 10 to the power of 7 into 9. This will get 40,477 angstroms. Okay, here you have to remember we converted in angstroms. Why? If we observe our options, this will be in angstrom. So hence our option 4 is correct one. Okay, next 15th one. When hydrogen atom emits a photon in going from n is equal to 5 to 1. N is equal to 5 to 1. It is going from n is equal to 5 to 1. Its recoil speed is almost. They ask to find what is the recoil speed. Okay, it is going from 5 to 1. It emits the photon, that is h nu. Okay, when it emits the photon h nu, we know the relation 1 by lambda is equal to r z square 1 by ni square minus 1 by nf square, and we know the relation lambda is equal to h by mv. Okay, and here another relation we have, energy and mass is equal to mc square because it emits the certain amount of energy. This we can written as, this is photon, so that is relativistic mc into c. This in electromagnetic wave, our energy is changes to mc square, mc into c. This mc is E is equal to mass into velocity, so momentum only now p into c. And then momentum p is equal to E by c. This is in electromagnetic waves. When you get the photon relations, that you have to remember. Generally momentum p is equal to m into v, but in photon, that is relative cases, will use E by c in electromagnetic waves. This momentum we have p is equal to E by c. So they asked to find recoil speed for hydrogen. So momentum of hydrogen is equal to that momentum of photon, that is equal to energy, that is radiating energy, how much it is radiates, by c. So this momentum is mass into velocity, okay, is equal to energy by c. Then here energy from 5 to 1, so this will be changed to this mass of hydrogen, nothing but mass of proton, that is 1.67 into 10 to the power of minus 27. We need to find v, that is recoil velocity, and E is what? 13.6, 1 by ni square minus 1 by nf square by c. Then V is equal to 13.6. Here Z square, Z is equal to 1. 1 by Ni square, that is 5 square. 1 by Nf square. From where to where it is coming? From to 1. 1 square by C 3 into 10 to the power of 8 and 1.67 into 10 to the power of minus 27. So after do this calculation, we'll get nearly 4 meter per second. Okay, now if you check which option is correct, option 3 is correct. Okay, clear? So this is our problems related to concepts. These problems, if you practice twice and revise the concepts, definitely you will get 4 marks. There is no doubt at all. Okay, once again go through this all concepts and problems. Okay, with that, this is our module 2. So what we have to do, practice the problems once again and revise the all concepts so that it will be easy. Okay, with that our module 2 will conclude. We'll see you in next module with new chapter. Thank you.